So we're still admitting participants. It's fantastic to see so many people joining us. But we still have 1 minute to go before we start. So please keep yourself muted. That will help. So we're still admitting participants. It's fantastic to see so many people joining us. But we still have 1 minute to go before we start. So please keep yourself muted. All right, it's 3 o'clock here in Denmark, Copenhagen. Thanks again for joining us. We have 100 participants with us, and this number keeps rising, so that's really fantastic. Our speaker today is Simon Klein from the Office for Climate Education. And for the next hour, we'll learn more about the topic of climate change and land, and understanding how to teach this topic better. I know Simon has a fantastic presentation prepared, an interactive one, so it's going to be really exciting. But before I hand it over to him, I just want to say a few house rules for this webinar. We ask everyone to keep yourself muted during the presentation. You can use the chat if you like to ask some questions for our speaker, and we'll collect them and try to answer some of them during this webinar. We'll also be using WooClap, but Simon will present that whenever that is relevant. If you have any technical questions in terms of this meeting, you can write me a direct message, Christina Madsen, or Alexander Carment can also help you with any technical questions. I also want to let you all know that this webinar is being live streamed, and we're also recording it so we can publish it afterwards. Thanks again for joining. I'll now leave the floor to Simon.
Thank you very much, Christina. I hope you hear me well. I'm going to start with sharing my screen, putting everything hopefully working. Is it working?
Yes, we see it.
Okay, perfect. All right, so thanks, the FAE, for inviting me for this very nice webinar. So I'm Simon Klein. I work at the Office for Climate Education, which is a organization based in Paris, working with the UNESCO and specialized into the climate, like the promotion of climate education through development of resources and workshops such as this one. I am myself a former researcher. I used to work as a pollinator ecologist, and I used to teach as well a bit, and now I'm working as a science educator kind of thing. So my daily job is kind of like to link the knowledge from researchers towards the teachers, and therefore they can actually hopefully teach better or have like a better idea how to teach the climate change issue with the kids and students. And basically the Office for Climate Education, as you can see here with the Eiffel Tower, is based in Paris. And we are this small team of 7 people working all together. We're all like former researchers or communicators and teachers. And we are all working in 3 different languages, basically like English, Spanish, and French. And the executive team, either it's like actually based in Paris, but we do work with a lot of researchers and educators from a lot of parts of the world. As well as the FAE director, Pramod, who's part of our steering committee kind of thing. So we kind of like work in that kind of like way of having a high scientific standard, but also high education background, and we try to keep updated onto like the new kind of pedagogical tools. And we work like mainly with primary and secondary school like teachers. If you want to contact us, just do not hesitate. Use our contact at oce.global. Sorry. And without further ado, we're going to dip into the subject, which is actually understanding the issue of climate change and land. So it's basically like I tuned it towards land, and you're going to see it. The first part, we're going to go through what is climate change, and then second part is more about soil, alimentation, and agriculture. Both part are more like, you know, scientific background kind of thing, and the last part is more about like small tips about how we can teach it, and also presenting a few resources that we do at the Office for Climate Education. And I hope we're going to have the time to actually share experience as well. So I prepared a Padlet to do that. I'm going to try to make it quite interactive, because I know that, you know, online workshops and stuff are not the best for being interactive, but please, if you have any questions, just type them on the chat, and then I'm going to collect them at some point during the presentation, like I think at the end of the part 1, then at the end of part 2, and at the end. And if you've got a chance, maybe we can like have a, you know, phase conversation, something like that. But without further ado, we're going to start with the first part, and we're going to look at proofs, the greenhouse effect a bit, and also just a bit about projections. Just before we start, I'm going to share with you at the end through the fair the link for that presentation. And what I did actually, I put quite a lot of information, links, videos, and stuff like that in the presentation that I won't have time to actually go through today, because like 1 hour is quite short. But please have a look at it later, and you can click, you can see it's like an interactive kind of like presentation. So you can click whenever it's clickable, and you can have a bit more of an insight of the scientific background. And before we start, if you guys want, we can have like a small quiz. I use this platform, which is called WooClap. So there is a link. I'm gonna put the link on the chat, and you can either use your phone or your laptop. And once you just like, either you scan the QR code with your phone, or you use that like the link that I just put on the chat, and then you may be on a, yeah. Either you tap wooclap.com and then / and webinar fair, like on caps lock, and we will be able to be quiet together to answer the questions. All right, so it's kind of starting. A few people are already in. Okay, people are kind of tired. So like the first question is like, what's your mood today? I won't be able to type in it, but I'm quite excited actually to be with you today. Quite a lot of tired. Okay. Wow, okay, it's getting bigger now. I'm happy to see that good and happy are quite big still. Even so, we've got, oh, it's moving quite fast. Can you actually see? Yeah. All right. Depending on what hour of the day you are, I think your mood is quite different. But for me, it's like 3 in the afternoon. I'm quite excited. I had a nice cup of tea. So yeah, here we are. All right. I hope you're all still here. And we're going to go with the first question. So please, to you on knowledge, whatever, what is the temperature increase over the last century? Like the mean temperature increase that we saw since 100 years through different collections and stuff. All right, I will go back to the question after the first part. So basically, just have a look at it, and we might go through it during the presentation. So you might be surprised about what you thought, and then I'm going to go through it anyways with the answer at some point, just to, you know, be a bit more on the same page. Yeah, so we've got like almost 100 people connected together on the WooClap, which is good. All right, it seems to be that people are estimating about 2 degrees. We're going to see that. All right. I'm going to move on to the second question. How much does the sea level rise each year? So as you may know, climate change actually affecting the sea. We won't see that in detail today, just saying, because we're going to focus on land. And basically, there's so many stuff to say about climate change and ocean sea level rise and the cryosphere. But I'm gonna give you some links and resources that we developed on that topic. So we might see that, I'm not sure, but I'm gonna answer the question as well. So as you may know, climate change is directly linked with sea level rise that we see everywhere on the planet. So it's a global rise of the sea level, which is basically due to 2 or 3 phenomena, such as like the dilatation, the increase of the water place in the volume due to the increase of the temperature of the water, and also like the fact that sea ice is actually melting and the glaciers as well. Sorry, continental ice is melting and the glaciers as well. All right, so again, 3 millimeter, 3 centimeter, we're going to see that as well. According to you, the greenhouse effect is either a natural phenomenon or anthropogenic phenomenon. You can actually, if you want and if you know it, type 2 answers on that one. Yeah, we're going to see that. I'm going to make a point on that. But it's quite interesting to see that like there are more people thinking it's like anthropogenic phenomenon. All right. And then, since when have scientists been studying climate change? Since the antiquity, for the past 200 years, since the 50s, in the 80s, or since 2000? Since the 80s is when ABBA started, maybe? Or, all right. Okay, we're going to see that as well later. So climate change is, we're going to see that later. So the climate change we have been observing for the century, so since like early 90s, is caused by variation in the sunlight, anthropogenic variation in CO2, natural carbon cycle, the precession of the equinoxes, volcanic eruptions, or the ozone hole. All right, interesting. What I might do, because some of the answers I won't go through it during the presentation, but I might give you some more resources later today or like in a few days, because this one's an interesting one. Okay. All right. Why is the greenhouse gas with the highest concentration in the atmosphere? So when we talk about greenhouse gases, we talk about a few of them here, but we should add to the 3 ones the nitro oxygen. Okay, so the question is like the highest concentration in the atmosphere, the one that is like the more dominant, which is different from the one who had the highest effect onto the climate. And we're going to look at it as well. So basically, we've got 2 parameters, either the concentration, so how many gases in percentage we have in the atmosphere. So basically, how many molecules of this, either carbon dioxide, CO2, water vapor, so H2O, or methane, CH4. And the other question that is not here is about like how big in terms of the effect onto climate change this particular gas is having compared to others. All right, so carbon dioxide for 70% of you guys. Interesting. All right, a bit of math. Eating a 125 grams, so half a pound of beef steak emits as much CO2 as driving 1 kilometer by car, 10 kilometers by car, 50 kilometers by car, or 200 kilometers by car, implying that you're...
So sorry, Simon. I muted you. It wasn't on purpose. Oh, can you unmute yourself? Simon, do you hear me? Simon?
Please unmute yourself, Simon.
Oh, okay. Sorry.
No,
All right.
it was my fault.
That's all good. I thought you unmuted me, but you couldn't. Okay, all good. I'm back. All right, let's go to the next one. For a trip of 800 kilometers, the transportation mode that emits the most CO2 is the car, the bus, the motorcycle, the train, or the plane. All right. Okay. Yeah, you're going to see that as well. Seems that like a lot of people are thinking that the plane. I think that's a good answer. We're going to see that later. I'm moving to the next one because I don't want to have too much time on that one. The most important source of CO2 in a house is actually lighting, household devices, such as like a laptop or something like that, heating or air conditioning. So whatever you need for regulating the heat into your home, hot water production or breathing. Yeah, I think you guys are on top of it. Very good. Because heating and air conditioning, I think, is the biggest one. And we're going to see that one solution to that is actually to get better houses insulation. And that's pretty important for the future as well. All right. Okay. A general question that we might go back to is actually, in your opinion, whatever teacher you are, in which classes you are, when do you actually, yeah, good one, actually teach climate change? And I think if you all agree on that, all topics are the good answers. Yeah, that's true. Everything you can connect, even the arts, even languages, even, I mean, anything. Climate change is such like a systemic issue that any topics can be related to it. And that's very precious because you can actually teach climate change through various entries and angles. All right, so thank you. Thanks a lot for having played that little game. And let's go back to the presentation. So we're going to start with what we see right now and since 100 years already about climate change. And the first one is about the temperature and the global temperature. And we see that there is an increase, and that's obvious, and that's scientifically proven, and there is no doubt. There is an increase of the global temperature in the land and the global one, and in water as well. So that graph here, you can see that the increase in mean, so basically what we call the anomaly, which is the difference between the mean calculated back in the 19th century compared to what we see between the 1815 and 2020. We see that there is an increase, and this increase actually around 1 degrees up to 1.5 degrees inland, and globally it's 1 degree. So to answer the question, it was 1 degree. And basically what you see is like it's kind of like red everywhere. So that's a heat map looking at the difference in terms of the mean temperature of 2019 compared to what it was only 40 years ago. So and this kind of video, I won't play it, but you can have it on whenever I share the materials. You can see on that quite famous video that actually it's getting red and red and redder. So basically the year after the year, since like 10 or 15 years now, it's like we hit more and more records in terms of a global increase of temperature in the world. So that's the first kind of like proof. And going with it, we can click wherever here, you can see that there are just like few examples, but you can take other examples to show that the global there are global consequences that are already in place everywhere in the world due to climate change. So one example here is the decrease by melting of the ice, the snow, sorry, in the Kilimanjaro mountain in Africa. And you can see in the drawings on the left that, and with this graph here, that between 2002 and 1912, so 90 years only, so it's like a human lifespan, there is a decrease of, I mean, 6 times less snow on the Kilimanjaro. So that's the same case in a lot of glaciers and snow on the planet. And those, one of the consequences of that one, like the melting of continental ice in the Arctic, on Greenland or Antarctica, as well as glaciers, is actually increasing, like making an increase in the variation of the sea highs, of the sea level, sorry. And so, as you can see, it's like a trend of like a constant increase in terms of like the high in the water, and it's around like 3 millimeters per year. So that's for the answer. Then when we click in here, what we see is because of the increase of the land heat and temperature, we see an increase of desertification. So that in this graph, you can see that there are more and more people. So the population in the area experiencing desertification is actually increasing by more than 200% since 1961. And a correlation of that is actually a decrease of wetland extent, and as well as the drought here, which is an extreme event, is actually decreasing as well in average. And that's what we see here as well. When we look at all of the extreme weather events, such as floods, hurricanes, as well as droughts and heat waves, and bushfires and stuff like that, we see that there is an increase of incidences. So the frequency is actually increasing everywhere on the planet. So it's like a accumulation of all of the extreme events per year everywhere on the planet. What we can't see here is actually another aspect of this extreme events, actually, is intensity as well is increasing. All right, so that's quite demoralizing, but we know there are proofs already that climate change is actually occurring on the planet. But what is the cause of climate change? What is the basis of that? It is what we call the greenhouse effect, and I'm pretty sure you all know of it. We're going to go very into it because it's quite simple, but as well quite complicated. And what we can know already is that the humankind and societies know about climate change, and at least about greenhouse effect, since quite a lot of time. So since Eunice Newton-Foote, who was the first woman, actually the first one who actually looked at the effect of the sun energy into the air and into the atmosphere, and the fact that the sun and the energy in the atmosphere is increasing the temperature when we have CO2. It was her, Eunice Newton-Foote, back in 1857. And then we've got those two guys, Tyndall and Arrhenius, and they were all working the same topic about the link between some gases, such as the water or methane or CO2, and how those gases actually interacting with the energy from the sun and the energy from the earth, and to keep the energy inside. And we're going to go into it. So to answer the question, it's around 2,000 years ago that we actually looked at it already. So I'll just leave you a few seconds. We won't have like a Q&A about it, but could you think about any ways to explain quite easily with your student what greenhouse effect is? So I'll just leave you about a few seconds to answer it, and I'm going to show you one little video that we developed at the OCE, and that can answer that question. So basically, one way to actually present it to, like, young student is to use very simple element that we have. We all have it, and you can have it in any schools because it's very easy to get. So it's like an analogy experiment on greenhouse effect, and we're going to use chocolate. So you need a glass, you need little chocolate chips or squares, actually 2, and a black background, which is quite important to increase the, and then you place it, the background under the sun, and you place, you're going to see it, yeah, you place one chocolate without any transparent cover on it. So you can use a glass. You may do different types of experiment with glass or plastic, but they all have to be transparent because they all have to leave the heat to get like to reach actually the chocolate. And you wait a bit for 20 minutes, and then what you should see is actually that the chocolate under the glass actually melted more quickly than the one which was not covered by a glass. So by covering the chocolate, you actually play the same role as greenhouse gases such as CO2 or methane or water in the atmosphere, and you do what we call a greenhouse. So that's just a little way to show it to students. And another way is actually to have a more like specific material and to actually look at an increase of the temperature. To do that, you use just a thermometer, and you either use the sunlight, as we did in the video, or you use a lamp. But be careful, because you need to have a light bulb that is not a LED, sorry. So it should be a light bulb that can be like, that actually produce heat. And you place the thermometer without the glass, and one with like either plastic container or a glass container at the same distance of a light source, and just you wait, and then usually what you see is actually an increase. The increase of the temperature is like higher and goes quicker under a greenhouse type of thing. I will just mention it quite quickly here. Those two experiments are like analogies. They are not actually reflecting the correct phenomenon, for the simple reason that you cover everything. So the air inside the container is not circulating. And in the atmosphere, what we see is actually there is circulation of air, right? So basically it's like an analogy of what a greenhouse is, a greenhouse for like, planting tomatoes and stuff, but it's quite not like the way it's working in the real atmosphere. And the way it's actually working is like through what we call infrared, those wavelengths that are like in terms like that are like smaller than, longer than the visible wavelengths. So basically whatever we see and a bit bigger of that is like infrared, and the infrared waves are actually the ones that are like conducting heat. So the temperature is actually increasing by infrared. If the infrared are very big, and if the heat is very big, then we can see it, that the sun, but any type of objects, even us, we are irradiating infrared waves, and those ones, we can't see them unless we have like those special cameras to see infrared, right? So any types of objects are actually emitting infrared when they're actually collecting heat, infrared or visible heat, from the sun or from a light. So for the specific case of climate change and the greenhouse effect on the planet, what's happening, and I will be very quick, but we can go like again with questions if you want, is the sun is actually emitting either visible wavelengths as well as like infrared wavelengths. Some of this energy, we're going to call it energy, right? Some of this energy is actually going out when it's like entering the atmosphere, but a lot of it is actually reaching out the planet. The planet's gonna stock it, gonna store the energy and re-emitting it. So there is what we call the infrared radiation. So like a second emission of heat, of radiation from the planet that has been heated by the sun rays. And this infrared goes out and gonna reach the atmosphere. And once it's reaching the atmosphere, the same process is actually happening. So the heat that has been collected by the planet has been re-emitted. Half of the heat actually has been re-emitted. In the atmosphere, any type of CO2, any type of methane or H2O, any gases, going to have the same behavior. You're going to collect the heat and going to store it and then going to re-emitting it. So like there is another infrared radiation from the different particles, from different gases, and it's going to go into space and back into the planet. So basically what's happening is like there is like a second emission of infrared, so of heat, going from the atmosphere, one, like half of it back into the space and half of it back into the planet. And what's happening after? This heat gonna reheat the planet gonna store it and then re-emitting it via infrared radiation. And same process. And each time we lose half of it. But basically at the end of the day, we have kind of like a ping pong kind of thing between the planet and the greenhouse gases. And what's happening is like the covering and the increase of gases in the atmosphere going to block more and more with this process the heat that is collecting from the sun. So basically, without any atmosphere, the planet and the temperature of the planet should be minus 18 degrees. So thanks to the atmosphere we have, we reach around like 15% in average of natural temperature on the planet. So the greenhouse effect is already existing through natural and like the natural processes of the atmosphere. But what's happening since 100 years now is that human activities are increasing parts of the CO2 gas, like the greenhouse gases, such as CO2 or methane, for instance. And because of anthropogenic, so basically the human activity increasing of the CO2 or CH4, for instance, this effect is actually increased. So the greenhouse effect is natural, but the increase of greenhouse effect is due to human activities. So to answer your questions before, the two options are good, but what we see now is like a combination of natural effect, which is regulated. So the natural effect is happening, but is regulated thanks to what we call the carbon cycle. But human activity are disturbing the carbon cycle and are increasing this effect. And that's why we've got an increase of temperature and all of the effect that we saw before. And what are the greenhouse gases emitted by human activities? There are all of those ones. Water is not it's emitted by humans, but the water circle, the water between the clouds and back to the sea and stuff is naturally regulated. So there is no increase of water in the atmosphere thanks to human activities, but there is an increase of carbon cycle, carbon dioxide, methane, nitrous oxide, and fluorinated gases. We're going to see a bit more about a few of them. All right, and that's another way to see it. I won't go through it, but there's a website that I put here where you can see every type of activities that humans are doing, such as like transportation, electricity and heat, energy, agriculture and stuff. And you can see which type of greenhouse effect are actually produced by that one and what are the different parts that are producing. But that was as a society itself. But what we can do is actually look at our own carbon footprint. And we won't do that today, but again, you can have a look at the presentation and you can play. I really encourage you to do it. Is a little animation that we developed at the Office for Climate Education. So it's an online application where you click here and then you answer a few questions. You answer a question about where you live, and you're going to see here on the right that there is a kind of like a sink of the CO2 emissions that you produce in a year as a person. And you can see anytime, I mean, at first, when you click on one continent, you're going to see that there is already like a stock of carbon that any families in your continent is actually emitting, which is due to infrastructures, the way the policies are made, and the plastic and stuff like that, that you can't really have a say unless if you go voting or protesting and stuff like that, but it's more about like a common share of your footprint. But then when you answer the questions about housing, transportation, food, and consumption, you're going to see that this little sink of carbon going to increase depending on the answers you say. For instance, if you say about you go to work with a plane, for instance, then they will like skyrocket for sure. But if you say here that you eat like local food and you're vegetarian, then that's going to increase. So I really encourage to do it. We won't have time to do it together, but yeah, it's a good way to go into that, and it's a very good way to teach your students and to open discussions about climate change and carbon footprint. And that's for the future. So I won't really go into details. We can go back later or like do another presentation about it because there are a lot to say about it. But there is a body which is called the IPCC, which is a consortium of different researchers who are working since like 30 years now on collecting information about climate change. And they are making projections, they are making predictions and scenarios. And they are like kind of like analyzing together the impact, I mean, the phenomenon of climate change and also the human activities, and how both are like, linked together, and how they can increase or decrease the effect of climate change in the future. And here you can see, I just put that one. They do estimation of the emission of fossil fuel and cement. So basically, the CO2 that is due to use of oil or construction in the atmosphere, according to different scenarios that they list, and they made kind of like predictions with a lot of like modeling and stuff like that. But what we always do is that they have like a very pessimistic scenario where it's kind of like business as usual and societies do nothing at all to protect ourselves from climate change by changing our habits, or they do a very optimistic scenario, which is here. And you can see that with an optimistic scenario, we try and we tend to go under to stop emissions and to either store some of the CO2 which is in the atmosphere thanks to reforestation, for instance. So that's it for the future, but I really encourage you to go into the things if you got time. We're going to quickly go back to your answers, and then I'm going to take questions as well. So basically, if we go back to it, I'm going to correct it very quickly, but I think you got the idea. Basically, what we saw is like more like 1 degree only, but you see how much harm and how much like catastrophes and how much like sea level rise and how much is done by just 1 degree. So imagine what's happening. Imagine what will happen when we're going to reach like 4 degrees in average. Then how much about the sea level rise? So it's like, again, 3 millimeters, quite a few. But again, think about all of the islands are like already disappearing because of a very small sea level rise. So imagine what will go happen if it's like 3 centimeters. I said it's like both. Then I say as well, it's like for the past 200 years. So it's quite like, it's like a good reflection about like how we actually listen to scientists. All right. Then it's like only the anthropogenic variation. I won't go into what the ozone hole here is, but it's like a very common mistake. Ozone hole is not ozone can be a greenhouse gas at some point when it's very high in the atmosphere, but the ozone hole is a different topic and it's not related to climate change. Then it's water vapor, it's like the highest in concentration. Then it was 200 Ks per car. So those questions, they can be answered by playing the carbon footprint animation. So I won't go further into that, but that's the car, and that's just due to the fact that we consider that you actually drive your car alone. And when you're on a plane, hopefully a lot of time you're not alone. So that's the difference. You were correct, the heating and air conditioning. And that's it. So yeah, if there are any questions that I can answer now, I will do it. And
I didn't see any questions per se on the chat. Quite a few are interested in the presentation. It does sound, yeah, it does have a lot of valuable links, so that's really exciting. And we'll publish that together with the recording of the webinar on the WIRI website. I've posted it, the link where we'll share it afterwards, but I'll post it again. So if anyone missed it, I see Janet, you have your hand up. Is that a question or?
Yeah, I didn't know it was here. So Gian is one of my colleagues, and he's actually taking care a lot about like putting you guys in touch with the resources I mentioned in the presentation. So it's good. One question: if the amount of water in the planet remains constant? Yeah, correct. Correct, because it's like a different cycle as the carbon cycle. Again, carbon cycle, if you're interested in that, we've got a resource on our website talking about it. But what's happening is basically the water cycle is very independent from the carbon one. And there is a regulation thanks to the atmospheric currents and the clouds and the evaporation of water in the ocean. And that's constant in terms of like the time of residency in the atmosphere. But what is changing in that water cycle actually is the intensity and the rapidity and the irregularity of the phenomenon. So, and that's because of climate change. Because the climate is changing anywhere on the planet, and there is an increase of temperature, and ocean and atmosphere with the water cycle are playing together to try to regulate the increase of temperature and to make kind of like that. We have to think about it like that way. It's like the combination of the atmosphere and the ocean actually playing together to try to like buffer the increase of temperature by putting the temperature quite like even on the planet, but that is like causing changes in a lot of phenomena that we have in the meteorological kind of like a normal cycle, such as the El Nino or La Nina phenomenon that some of you may know. So yeah, all I want to say about water is like the water content is like quite it's like not, but like it's quite constant in the atmosphere, and it's not increasing compared to carbon with methane or CO2. I want to ask people how to work on that. Yeah, I'm going to go through that later. Does attitude of people significantly contribute on climate change? Yes, the attitude of people significantly contribute in climate change. And we talked a bit about it. And I really invite you to look at this carbon footprint or the website I just mentioned before, when you can see all of the activities that human society actually having, and that explain the emissions of greenhouse effect. We discussed as well about water degradation and evapotranspiration, natural mean to purity and polluted water. Yeah, pollution is very different from the topic now, so I won't go into details into that, sorry. It still works like that in the current situation? Yeah, I won't be able to answer that question because I'm not even sure I can.
Simon, I think Janet has a question.
Thank you for that. One of the questions and concerns that I have is quite often the discussions about climate change are very, I think, Eurocentric orientated. So there are concepts that are very difficult to achieve in certain, and I can only speak on an Southern African context. But for instance, the greenhouse, we use that terminology quite flippantly as if everybody understands what a greenhouse is. Mm-hmm. And it's not necessarily, where people don't have greenhouses as a normal, and they don't see a greenhouse. Now you have to explain the greenhouse before anything else. So we use often the car effect, which makes logical sense. So if you have a baby left in a car that's all closed up, what is the effect going to be? That kind of scenario. The other concern that I have is when we immediately put across these terms, how much meat would you eat would be appropriate and linked to the kilometers that you would drive, is very much a different concept within an area where the grass fed and the benefits to cattle eating the grass and reducing the amount of carbon emissions, possibly by fire. There's a lot more complex than just using quotes and terms that are, as I say, possibly gained on a Eurocentric approach rather than on a global approach, if I can put it that way.
Yeah, I'm following you a lot on that. I'm very sensitive to that, and I'm very sorry that again we present very Eurocentric examples and Eurocentric way of seeing that thing, and that's a big drawback that we have in Paris with our team, and I'm really much like I really desire to actually change that and try to drive towards a more universal way to present climate change, because it's a universal topic, as you said, but also because that concerns everyone on the planet. But I also see a lot of difficulties to do that. And the way we work as an organization, as an NGO, is to produce as a default Eurocentric productions, because that's the way we work with scientists here. We try to be less Eurocentric as we can, but there's a bias that we can't fight. But the way we work is actually we work with partners a lot in South America at the moment, and we try to do adaptations of our resources, and we try as well to gain knowledge from their own perspectives to change our way to work in France or in Europe. To include more and more inclusive and as well ways to present those topics. So I'm very happy you raised those points, and I mean, for now I can't do anything else because that's the way we worked, but I keep that in mind, and I hope we all keep that in mind as well, that education has to be tuned towards our own contexts, and there is a lot to learn from what we call indigenous education and indigenous knowledge, as well as that indigenous knowledge topic and the local indigenous habits and stuff like that are actually mentioned in the IPCC reports to be one of all of the solutions we can think about when we want to fight climate change. And I'm pretty sure that we need to be more aware and more careful about including local context, examples, and ways of thinking and ways of actually explaining the environment. And we need to protect that knowledge as well in a way. So yeah, I'm very thankful for your intervention, and I mean, at the OC, I hope we're going to work on it a bit better. But yeah, we should be careful about it. Thanks.
The time is flying, Simon.
Yeah,
sorry.
I know. Sorry, I go for the second part, which is again a bit European centered. There is that's for you guys because I won't go into it today. But a thing that we can do when we want to teach about climate change in land is actually to start with what is land, and a way to present what is land to students, actually to a simple way to do it, actually to go into the forest and to do field work and stuff. But another way to do it is actually to work with terrariums, and we did a small, when you're going to click on activity, there is a link here on a video on, it's the same way we had the video before about climate change and the greenhouse effect. This one's about how to build a terrarium and what are the pedagogical aspects you can use in class to actually work with students about what is soil and why soil is important and land is important for us as society, for plants, for animals, but also for the climate. So that's more of an introduction, and there's part about the biodiversity, but I'll leave you with that for later. And when we talk about soil and human activities, we therefore quite often go towards alimentation. And that's the thing I want to present to you a bit. That's another activity that you can do with your class, is actually card game where you have to sort out different types of food in terms of how much carbon has been emitted when we produce that type of food compared to another one. I'm going to show you very quickly how it works, because that will be easier to understand. And I invite you to play later on if you want. So here you've got one card in the middle, and it states how much CO2 was emitted for producing 150 grams of carrots, for instance. And then what you have to do is to sort out if the milk has a higher or lower carbon footprint. I think is higher, and I think we all agree on that. So you place it here and you see that, yeah, it's higher, so I won. So you're gonna stay here. And then potato, I'm not sure, it might be lower. No, it's actually between those ones. So I'm wrong, and it goes back towards it. So yeah, very quickly, that's the way it works. And that's a good way to actually talk with the students about the hidden cost of a product. Hidden cost of a product is actually based on what we call the food cycle. And I'm going to be quite quick as well here, because I want to present to you. So that's another video of me presenting the food cycle and all this kind of like stuff about alimentation. It's online. It's got subtitles in English when you go here, and you've got subtitles in English if you want. Otherwise, it's in French. But there's a way I present the food cycle by saying that if you want to have like a industrial cheese, you need to have a cow that is actually producing the milk, and the cow is actually eating grass or soy or maize. And those ones, that's the production, that's the first part. And then before that, you actually need another part, which is the production of the cereals and the maize that the cow is eating. And the first part is actually what we call in French intrant, which is more like the fertilizers. So you're going to need fertilizer to get like your crops growing, to get like enough food to feed your cow. And that part is very like emitting a lot of like N2O in the atmosphere, which is a greenhouse effect gas. So we've got already two steps. The first step is like producing food for cows, and there are like two effects of that one on the atmosphere. First one is like fertilizers, and second one is like in a lot of time you actually cut trees to grow crops, and that's emitting CO2 in the atmosphere, either by combustion or either because you actually decrease the carbon sink effect of forests. When we go back to the little cow and we look at the belly of a cow, we see that there is this biological symbiosis between bacteria and a cow and the cow's stomach. And those bacteria are actually digesting the grass by emitting via fermentation methane in the atmosphere. So that's another very high emission of atmosphere, greenhouse effect in the atmosphere. Then once we've got the milk, we're going to collect it with a truck, which is emitting CO2 in the atmosphere. And we're going to go into a usine in France, like a factory to make the cheese, about what we call like processing or transformation. And that also induce greenhouse effect in the atmosphere. Then we can like, convey the cheese into storage, like central bodies where they collect all of the goods together before distributing it into small shops. So again, we've got transportation, and then that is going to go into a little shop, and the shop is very close to our house, but sometimes we need a car to actually go and collect our cheese to eat it. So the car is also emitting CO2 into the atmosphere, but at some point we're going to eat it with some wine because we're French, but if you're not French, you can also drink wine and eat cheese if you want. And that's what we call consummation. And once you finished, you're going to like sort out your waste, and you're going to produce waste. And a bit of your waste might go back into fertilizers, such as urine or feces. So that's for a very rapid and very, very like schematic, and it's pretty much a industrial, like the most industrial kind of like way of producing cheese, for instance. But we've got like other ways to produce it, just like, a small farm, and you go directly to the farm to get the cheese out from there. the taste is going to be better, but also you're going to reduce a lot the emission of greenhouse effect in the atmosphere because you're going to shortcut a lot of those little steps. All right. And when we look at the different like carbon footprint, that's the average of the different steps that I showed you before. So agriculture, transformation through like processing through industry, the transport and so on. And what we see, that one was for France, and it's like in average for any types of food. What we see is like in average, the agriculture is the one that is emitting way more greenhouse effect in the atmosphere than the other ones. And that's including CO2 in green, but methane a lot with cows and sheep, and natural like NTO, which is based on fertilizers. And that's a small presentation to talk to you about the differences between those three different gases. Nitrous oxide is the one that actually has a higher effect in terms of greenhouse gases, in terms of like greenhouse effect. So that's for the alimentation part and the agriculture part. I'm not sure about the timing, because we can go through it, or I can, skip that.
We have 5 minutes left.
Okay, I'm gonna skip that.
But yeah, if we go 5 minutes over time, I also think that it's
okay. Sorry. So I'm gonna, give you the presentation after, but it's basically a small topic that we engage as well, is the link between agriculture and biodiversity, and we take the example of pollination and pollinators. So you're gonna have to see that by yourself, which is good. And then to finish on agricultural part, we saw that agriculture can be linked to climate change by impacting the climate. But what is also very true and very important is that the climate is directly impacting farmers everywhere on the planet. And that's where it's very tricky, because in a lot of time, it's also in countries and within population who are like more vulnerable that those impacts are like the higher. But when we talk about like, drought or fire, like bushfires or floods, all of those effects are directly impacting those professions and land and land use, so therefore farmers. And we're going to finish with a few ideas of how you can teach climate change in different ways. So very briefly, we've got a full package about the ocean and cryosphere that we developed a few years ago, but we launched it this year, a few months ago. So please, if you've got time, and if you don't as well, just go back here. Gian did a very great job on the communication on that part. So basically, it's a package with a lesson plan where we provide like ready-to-use lessons, up to 16 lessons, about the link between climate and the ocean and the cryosphere. We've got a few like dissemination videos where we interviewed researchers who are working on that topic. So you can use those ones to either like learn yourself before like, doing your classes, or either like show that in like for students or to your friends and family. We also have like the animations, I already talked about it. And then we have a summary for teachers. So it's basically not for students, but it's directly a translation of the IPCC report about climate change and ocean and cryosphere, or about climate change and land. So we take the very hardcore summaries from the IPCC that are actually like for policymakers, and we make them towards you guys and us as well, like teachers. So basically, it's a digest of those very high level and very accurate knowledge about climate change. So I highly invite you to look at those guys, those things. So that's number one. And we also do what we call formation, but it's more like workshops, a bit like what I did today in very, very fast, but we do it in few days, and we do it in hands-on activities. And when COVID is not here, we actually, travel a bit and invite people as well. And we do that, and we hope to do that more and more. So if you guys are interested, and if you like in your country, if like there is like enough people or something with like a link with more like government bodies that are interested in working on climate change education, please just contact us with contact@oce.global, and we can talk about making those kind of like workshops. And we also want to develop network between teachers everywhere on the planet. So we do that on our own, but also thanks with Faye. And I'm gonna just finish on ideas of project that you can do in class. And I'm gonna start with the differences between project of what we call adaptation and mitigation. So adaptation is actually solution or ways of dealing with our daily life and our like cities or our countries and stuff, for adapting our societies to climate deregulation. So basically, everything that has to be with reducing the impact of heat waves on human health, or reducing the impact of tornadoes or floods into buildings, that's what we call adaptations toward the effect of climate change. Mitigation is trying to reduce our impact, so the emission of CO2 or methane in the atmosphere. So that's two different ways of fighting climate change. Either like living with it, and nowadays what we know is like it's too late to actually only do mitigation. And what we have to do is actually to adapt ourselves and our societies to the impact that we see already, and that are going to be like higher and higher. In the same way, we have to try to reduce our impact with mitigation programs, and sometimes they're like linked anyways. A few examples of what we've been working with is like having vegetalization and schoolyard, what we can call schoolyard greening, to fight actually heat waves in cities. Like that's very particular to France, but maybe other countries, where like for years and years the schoolyards were just like concrete, and that's it, and few trees, and that's it. And now what we're seeing is like way better to have like little cabins and wood and green everywhere, because that's actually a good way to reduce the impact of heat waves. Another way to actually work with students actually to work directly into food production, and a little fun stuff to do with students actually to work with aquaponics, where you've got a culture of fish linked with a culture of like herbs or vegetables. And another step that I won't have time to talk with you about is like what we do sometimes, like climaton. So basically, we propose to students to work together on a topic on their own, and teachers just like head them out, and they invite like researchers and experts to help the students to build up a project on their own. And if we've got a bit of time, while I answer questions, I really invite you to, if you can, just type here any ideas you have, or anything you did on your own, or any questions you have as well, like anything you want to share with us, but like mainly with others, like teachers who are like, all together today. Just feel free to use that Padlet, sorry. It's very easy. You just like click here and you can add something. And yeah, that might be a way to connect together or to get more knowledge. I'm gonna have an eye on this Padlet for the next few days. So if you got questions that you won't have time to like ask today, just please leave them here. I'm gonna try to answer it later. Thank you so much. I hope it was not too fast, and I hope you're all here. Namaste. Thank you.
Thank you so much, Simon. I know we're running a little bit over time, but it was such an informative and full-packed presentation. I think it was really, really fantastic, and with some fantastic ideas for also how to teach this in the classroom, because it's not always easy. I'm going to share once again in the chat both the link to where we'll have the recording published and the presentation, but also the link to OCE's website with the different resources that you presented. If anyone has one final question that they're burning to have answered, maybe we could stay on a few minutes.
Yeah, I've got nothing else planned anyway, so guys, I'm here.
But yeah, lots of thanks in the chat. So that's really nice. I do think also that this is a topic, like as we began with saying that this topic can be taught in any classroom or in any topic, right? So it's huge, climate change, and hopefully there will be more chances in the future with more webinars to address this topic.
Yeah, definitely. I think a good way is to have this kind of like overview, even so it was very quick and a lot to digest. But I mean, it's quite like necessary to get like into specific parts of it, but to keep in mind that any part that we talk when we talk about climate change is actually connected to another one. But yeah.
So thank you again, Simon. Do you have any last words before I close the meeting?
No, well, I don't know, just like, and another way, yeah, I'm not sure. I was like, well, like a very good way to actually talk about climate change with the students, to start to talk with them about how much nature is important, how much nature is beautiful, and a very good way to make them more and more concerned about it, actually to work on empathy with each other, but also like with nature and animals and plants and stuff. And what we see in France is quite sad in a way, but like we kind of like tend to like lose or miss the link between our society and nature. And that might be one of the biggest, challenge as well. So yeah, that's kind of like an important entry. And for you guys as well, like, just to go out from screen and to go into nature. That will be my final word.
Thank you, Simon. So yeah, you can please add to the Padlet if you have any ideas that you want to share. Simon, maybe you want to stop sharing your screen and we can just say goodbye to everyone, because it's nice to see so many faces.
How do I do that? Sorry. Oh, I found it. Here we are. Yeah.
So bye, everyone. Have a lovely day, morning, evening, wherever you are. Thank you so much for joining.
Bye-bye. Thank you.
Have a nice day, everyone.
Thank you.
Thank you so much. Have a good one.
Gracias.